It's good to be back to WLPC. I was at Phoenix in 2018, and a lot of things have happened since then. So I'm Karan Gupta. I'm working at Arista Networks, and I mostly lead the cognitive Wi-Fi track at Arista. And just a quick plug here. I'm also the person behind the packets tool, which allows you to analyze any packet capture online. And you can access that at packets.arista.com. It's free for sign up, free for lifetime, unlike CloudShark maybe. So please go ahead and sign up, and gives you nice visualizations to see what's happening in your packet trace. So today I'm going to talk about automated root cause analysis in wireless networks. And this is like a generic treatment of the topic, not necessarily what we are doing at Arista, but generally what the space is and why it's important. So why do we need automated root cause analysis, right? So let's talk about the problems that a client can face in a network. We have connectivity issues, and we have performance or application issues, right? Now for connectivity issues, you can monitor the AP state machine to see where the client is in that entire process. And what you can do eventually is say where the client is falling off or where it is facing the issue, right? Is it the association phase, authentication phase, whatever, right? So on. So this is a solved problem at this point. Pretty much everyone is doing this. But what about performance and application issues, right? So there is no state machine as such. There are too many variables, right? A lot of devices involved, right? So this is not an easy problem to solve when you're talking about, automatically understanding what's going on. So that's where a root cause analysis engine comes into the picture. Now, what is an RCA engine? And well, what's a Wi-Fi RCA engine? But what I'm going to show you is a generic framework for RCA engine in any field for that matter, right? So the first thing is a symptom, right? So we'll get deeper into each of these topics, but a symptom is something like a fever, right? You have a fever, that's a symptom, that's an externally visible thing that's an issue with the system. So for example, clients are facing low data rate, so that's a symptom. Then observations, right? So once you know what you're trying to figure out, like the root cause for, which is the symptom, you need data to understand what's going on, right? So that's where the observations come in. So this can be like a list of clients in the network with their properties. Then you also need domain knowledge, right? So depending on what domain you're trying to solve for, let's say in our case it's Wi-Fi, you need to know how different parameters relate to each other. Then system knowledge, what is the current configuration of the system, right, that you're trying to do root cause on. And once you provide all these inputs to this entity called the RCA engine, what you get is an output, which is essentially a set of root causes, like out of the many that are possible, right? What are a few that, potentially causing this issue, and a recommendation, like how do you mitigate those issues, and then evidence. So if you present this report to a human operator, right, obviously the operator would like to understand, okay, you are telling me this, but show me the evidence, right? So that's really important to build that trust into any such RC engine. Now let's look at each one of these individually. So what constitutes the observation? So if you are doing a network-wide root cause analysis, right, you want to understand, okay, what's happening at this location? I have many clients that are affected. Then what you would do is you would actually capture a list of all those clients and potentially also their historical data. And for example, things like whether it's facing retry rate or not, high contention or not. And you would have the symptoms. So the column on the right, that's your symptom, right? So right now, let's say we are looking at low data rate as a symptom. Why is there low data rate in my setup? So you see which clients are facing low data rate and each of their properties. So that's your observations from the network, right? And if you are doing root cause analysis for a specific client, you will just take all possible data for that client and try to understand what's going on. And observations, what you can do is you can actually, for simplicity, you can convert them into Boolean value, right? Whether a client is facing high retry rate or not, whether there is high contention or not. Now, given a value, some value of high retry rate, for example, you can convert that to Boolean by either using a static threshold, or you can do some, relative analysis that, based on your system. So there are multiple ways of doing that. There are other parameters like, which location the client is at, what vendor it is, what OS, what access point, what SSID. So these are like parameters which can be useful to correlate, okay, clients connected to this access point are most likely to have issues, right? So those parameters are also important. Now, let's talk about domain knowledge. So this is really important. It basically tells you how different symptoms and different root causes are connected to each other, right? So for example, let's say our symptom is poor application experience, right? So that can be caused by a low data rate, high retry rate, and so on, high contention. And you can see, like you can take this dependency graph and go back from there, and you can see, on the periphery you have certain root causes, and then, which are kind of dependent on each other, right? So this has to be built into your root cause analysis engine. So this is specific to Wi-Fi. We know how these things are connected to each other. Talking about system knowledge, this is also important because you need to know how the system is configured. Even if you're using the same vendor, right, the configuration for different locations, right, can be very different from each other. So that has to be taken into account when you are doing RCA, right? So for example, if DCS is on or auto transmit power is on or not, right, all those things are important to understand. And this really becomes important when you're recommending, right? So if you find a root cause and you say, okay, turn on auto transmit power, right, you need to know whether it's already on or not, right? There's no point in recommending that if it's already on. Now let's talk about the symptom, right? So it's really important to distinguish between a symptom and a root cause, right? So a symptom, as I said earlier, is an external, external manifestation of the failure. So for example, if a symptom, if you talk medically, fever is a symptom. Now there can be 1,000 reasons why you have fever, right? But it's an external thing that I can measure, that I have a fever, right? So in case of Wi-Fi, you can, at a top level, you can say there are two symptoms that you can focus on. One is poor application experience, and the other one is low data rate, right? So what we really care about is, the application experience on any given client, right, should be great, right? And measuring symptoms is itself an important thing. So how you do, how do you measure symptom is important. And other one can be low data rate, but low data rate is not a very good symptom to deal with because an IoT device may transmit at a low data rate by design, right? So what you really want to focus on is, whether the application experience is good or not. So that is what a symptom is, something that you can measure externally. So once we have all those inputs, we have this thing which we can call a RCA report, which has root causes, recommendation, and evidence. And you will see in that dependency graph, right? So root causes are events that are not caused themselves by other events. These are things that are really responsible for things that happen ahead. So for example, in this graph, right, you will see everything that's on the periphery of this graph, that's a root cause, okay? And we have a bunch of these. And the goal of the engine, any RC engine, would be to, detect that given a symptom, out of these many possible root causes, this scope, right? And this is probably not an exhaustive list. Which 2 or 3 or 1, is responsible for the issues that I'm seeing. And there can be other, sort of root causes, which are not really root causes, but you can say these are correlations. Like our clients at a specific location facing an issue and so on. So, and going back to the analogy, right? So if you have fever, right, well, COVID-19 can be a root cause potentially, right? Or you're just tired. So there can be multiple root causes. And if you have the root cause, the next thing that you want is actionable recommendations, right? Once you have identified what the root causes are, and you want things that can mitigate those root cause. So for example, for poor coverage, you can say increase transmit power, or you can say enable client steering, and so on, right? So there are like, depending on the root cause that shows up, there are like multiple possible recommendations that you can make. And the recommendations have to be smart. So for example, if you are saying, enable 5 gigahertz on your network, so we have seen places where people don't enable that. You need to know what the system configuration is, whether it's enabled or not. So the recommendations have to be smart based on what's the current configuration in the system. So this is the complete picture. This is what a RC Engine framework is. And as you can see, it's a generic framework, can be applied to any field as such. And this is the, this is what you can use to build a Wi-Fi RC engine as well. Now let's talk about what are the different types of RC engines. So in case of Wi-Fi, you can have 2 types. One is where you're trying to troubleshoot a specific client, right? Like someone called and that, I want to see what's going on. So this is done for a specific client. And the number of features that you can evolve here, right? The parameters that you can capture for a client can be a lot more because you're dealing with a specific client. And it's basically useful for debugging a client. Then the multi-client one is where you're doing network-wide. Like you want to understand, okay, I have many clients that are facing issue in a network. What's happening with them? Is there a correlation with something? Right, and here the number of features can be limited, and it's basically useful for debugging network-wide issues, right? You just want to understand, okay, I have like 50 clients that are not doing well, what's going on? So we'll talk about the MultiClient RC engine and the process there. So what you do in this case is you collect the observations that we talked about. You basically capture the data for each client. And then for each site or a location, right, because each RF environment is different, you don't want to combine them, right? So for each site, you essentially capture all those perf parameters and run it through the RC engine, which will then come up with the report for each location or site. And then you essentially rank them and display them on the UI, right? So for example, you have like 10 sites. For each site, you would run that and see what's going on in each site, and then rank and display the RCA statements. Now, how do you do this? So we have been talking about this RCA engine as a black box, but there are like different algorithms. I'm going to just talk about 2 at a very high level. And one is where you use a decision tree algorithm to see what the root causes are. And it's very intuitive. Like if you look at a decision tree, right, it's like a very intuitive, human-readable form. So what you do is you essentially have data, and you use that data where your target is whether the client is facing that symptom or not, and you train a decision tree model. So when you train a machine learning model, in this case a decision tree model, right, so they are really good at detecting patterns, okay? So if your client is facing low data rate, right, what might be causing it, right? But here we will not use the generated model to predict, okay? We will use it basically to see what it has learned from the data, okay? So we'll get into that, but let's look at what data we need to provide to any algorithm for that matter. So we need a list of all clients along with their Wi-Fi parameters, not only the ones that are affected. Okay, this is a really important point. Can anyone tell me why that's the case? Why can't I just have a look at the clients that are affected? Why do I need all clients? Well, yeah, kind of you're on the right track. So the idea here is, I'll demonstrate with this table why we need to capture all the clients. So let's say my target symptom is low data rate here, right? So my target symptom is low data rate here, and a few clients are facing low data rate and a few clients are not facing low data rate, okay? And let's start with poor coverage. So some clients are facing poor coverage. Basically, half the clients are facing poor coverage and half are not, right? So do you see any correlation with them? Like, is poor coverage the real reason? No, because pretty much 50% clients are facing poor coverage and 50% are not for each of these categories, right? So there is no correlation. So calling out poor coverage as an issue is not very helpful. Now let's look at capability. Let's say all of them are 2.4 gigahertz clients, right? And this also is not useful because there is no correlation, right? Everything is yes. So in either of these cases, there is no correlation between what the symptom is and what the root cause is, because it's all random, right? But let's say this is the situation for high retry rate, where most clients that are facing low data rate have a high retry rate as yes, whereas most clients which are not facing low data rate have a high retry rate as no. So there is a clear correlation between these two parameters, right? So in this case, the engine should typically say that, okay, it's high retry rate, which is potentially causing the issue. So it kind of filters out things that are not highly correlated between different clients. So that is why we need all the clients' data so that we can understand that, for example, someone may say, okay, 50 clients are affected, all are Apple devices, hence Apple devices is an issue. But what if all your devices are Apple devices, right? Then that vendor thing is not very important. So that's the idea here. This is a sample decision tree which can be generated with some data. So you can see that it's intuitive to read. So what this tree would predict is if there is high retry rate and the client is operating in 2.4, then the client is affected. That's what the tree has learned from the data, right? What we do is we just read this tree and we start from the leaf and we go back to the root and we say, okay, the statement is if the client is facing high retry rate and is operating in 2.4, that's when it will face low data rate, okay? So it's very intuitive, and the tree that's generated is very human readable, and you can generate statements from that tree. The other algorithm, which is somewhat more straightforward, is something called association rule mining. It's very simple. The idea here is that if we go back to the supermarket analogy, right? Like if someone buys oranges, right, what else are they likely to buy? Okay, so those are the rules that an association rule mining algorithm will try to understand. So it's typically used by supermarkets to understand like what to place where, right? So here too, what we'll try to understand if a client is facing low data rate, what are the things that are co-occurring with that, right? And then you can filter the rules because there can be multiple rules that are generated. You can filter them to come up with the most possible rules from your data, right? Now let's look at some examples of how it works. So in this case, once the report is generated, we talk about what are the top locations that are affected. So this is from a real customer scenario. So you see that there are like these many locations, and then what are the top root causes. And then you can dive into each location and you can look at each statement at that location. So for example, this one is saying clients have 5 gigahertz capability, but the network does not support that, right? So you need to turn that on. So it's a 2.4 gigahertz only network. And then the evidence is also there. So as I said, evidence is really important. So we also show the number of clients that are impacted by this statement and where they are operating and their properties. Now the second statement can be high contention, like there are too many BSSIDs on a single channel, and you also show what are the contending access points, and this is the list of clients that are facing this issue. And you can also see statements across all locations in one go to understand, okay, in this report, what are the locations, what are the different root causes across locations. And that's not where one would stop. As I said, like once you have the root causes, you would like to understand how to mitigate those root causes. So if, for example, let's say the root cause is high contention due to too many BSSIDs, you would say that, set transmit power selection to auto and enable dynamic channel selection. So this recommendation is a smart recommendation. It knows what is turned on, what is not turned on, and accordingly recommends what you need to do at what location. Okay. Now let's talk about the single client RC engine. Here the process is simpler at a high level. So you basically are dealing with one client. You're trying to troubleshoot one client. So you collect the observations about that client. You can collect all the historical information as well, run it through the RC engine. And in this case, the RC engine can be rule-based as well. And then you generate a similar report for that client. And for a given client, you can do like both performance issues that we saw and also connectivity issues, like is the client roaming aggressively? You can look at all the client connection logs and try to understand that. Is it trying to connect to too many SSIDs, or frequent fast roaming failures, or there is high DHCP, AAA DNS latency. So you can do this for a client. This is what a typical statement would look like. Like, the client is facing low data rate and high retry rate because of the following reasons. And to make it better, right? So once you are inside in context of a client, you would like to understand the context in which that client is operating. So what you can do is you can actually show a chart. Okay, this is where everyone else is. This is where your client is, right? And similarly, you can do that for the high retry rate. This is where the baseline is, and this is where your client is, so that you get the context given a client. And here is a statement again from the same network, right? Which essentially calls that client out as a slow client, BG client, and it potentially can affect other clients as well, right? So that's about the RCA, but where does it fit into this whole network assurance picture, right? Why is it important, and why do we need to automate it? So let's say you are doing anomaly detection and you find an issue in the network that more than usual number of clients are affected, right? At that point in time, you would like to do an RCA, right? You would like to automatically generate that RCA report instead of on demand. So for example, in this case, at that red dot, there was some issue which was out of ordinary, and I would like to understand what happened there, right? So, and this is what takes us towards this concept of a self-healing network, where you basically are monitoring the network, right? Some parameters, some symptom of the network, and you do anomaly detection on those parameters to see what's going on. The next step really is doing root cause analysis, right? So you see that there is an issue, right? Now you want to understand why that issue is, and then you run that once the RCA tells you, okay, out of 15, 20 possible issues, these are the 2 that are responsible for this anomaly. You run that through the recommendation engine and maybe send an alert to the administrator, which not only tells the administrator that something is wrong with your network, that's not good enough. You tell them, okay, we did the RCA, something is wrong with the network, and this is potentially why this is happening. And you also tell them, okay, you can mitigate the issue with these 2 actions. And obviously the holy grail in all of this is the network itself taking a corrective action out of those 2 things and potentially fixing itself. So this is obviously a vision, but the point I'm trying to make here is a very good or a solid root cause analysis engine is really important to realize this vision at some point in the future, right? So that's all from my side. Thanks a lot.